another class of algorithms in the bandit space, which ideally I should have spent a lot more time, but we are really running out of time in some sense. I do not want to spend too much time on bandits. I want to get on and talk about other topics in reinforcement learning. So, there is something called contextual bandits. Okay. So, what are contextual bandits? One way to think about it is to say that I am relaxing my bandit assumption that there is no state, I am introducing a state, right. So, this is like I am taking one step from my immediate RL problem towards the full RL problem, right. Now, so what did the immediate RL problem had? It had all this explore exploit trade off, right. It had the stochasticity, it had the noise in the selections, right. It had the fact that I knew about the rewards only through sampling, I do not know the true underlying reward distribution. So, all of these characteristic of the reinforcement learning problem it had, right. So, what is the third thing we are adding now? We are adding this state dependence, right. In different states I am going to have different kinds of reward functions. So, what is still missing? Sequential dependence. Remember I was talking to you about when cycling, I mean you might make a mistake initially, but then that is going to influence how hard it is going to be to balance in the later stages, right. So, I do not have that sequential dependence now, right. So, I give you a state, you give me an action, right, independent of what action you selected I will give you another state, right. I keep going like this. So, essentially what you are going to do is look at an input and then you are going to take an action, right, and then you are going to move on, right. You get a reward and then you will move on to another state. So, another way of thinking about it is to say that hey, I am not solving one bandit problem, I am solving a set of bandit problems, right, and I will tell you at every point which bandit problem we are going to solve. Okay, here is problem 3, tell me what is the option, here is problem 5, tell me what is your option, like that, right. So, one naive way to think about solving this, well it is not really naive, the way I have stated the problem, okay, is pretty naive. So, one way of solving this is to essentially say that okay, I am going to maintain, suppose I have 10 different bandits, I will maintain 10 different sets of action values or 10 different sets of policies, right. So, I am just going to do this all independently and I solve it, okay. So, that is one way of handling it. But what if I tell you that these problems can be many, not just like a handful, but I am going to have a huge set of problems, right. For example, I told you one of the success stories of reinforcement learning was in like those news story selections and ad selections and so on and so forth, right. People remember that? In the very first class I showed you some examples where I said Yahoo chose ad news stories to show on the web page by treating it as, essentially they are treating it as bandit problems, right. So, I have like 20 news stories, when somebody comes to the web page I will show him one out of the 20 stories, right, essentially like pulling an arm, right? And if the person clicks on it I get a reward of 1, if they do not click on the story I get a reward of 0, like it is like a binary bandit problem, right. But then if I solve it as a single bandit problem it is not very interesting, right, because that means that everybody who comes to the page will get shown the same news story, or if you go back again you will get shown the same news story, right. That is not going to be that is not a good thing, right. So, what you really want to do is depending on who comes to your page, right, so you want to be able to change your choices. So, one way of thinking about it is now to say that hey I am going to group all the people coming to my page, right. If somebody from group 1 comes I will use this bandit, somebody from group 2 comes I will use this bandit, somebody from group 3 comes I will use this bandit, right. Does it make sense? Right. Now, I have now somehow found a way of grouping them, right. How do I group them? Best, well there are too many options here. So, you could look at their browsing history, you could look at if they already have an account on say Yahoo or Google or something, you can look at the data that they filled in, right, and a variety of things, right. So, you can look at which country they are coming from, what time of the day they are clicking from, or they are browsing from a phone or from a laptop, right. So, there is so much information that each one of these internet sites gathers about you, right. In fact, they know more about you than you do, right. No, that is not as stupid as you think it is. In fact, there are a lot of times when people are consciously not aware of what they are doing, right, but then by watching the person's behavior they are able to form a more informed model about you, what you are trying to do, than what you yourself are doing. Quite often you are desultorily doing things, right. So, you do not really realize what you are doing, what you want. Anyway, so fine. So, you can do all kinds of things, you can group the users, right. Is there something you can do better than that? Which variables? Which variables?
The states.
Use include them.
As parameters.
Exactly. So, why would that help?
It would reduce the number of parameters.
It will reduce the number of parameters.
Instead of keeping separate parameters.
So for each person you can define a unique set of parameters and they'll have a separate problem for each person in that case. So based on
That is not interesting, right. That is going back to solving the same problem for, you do not want them to have unique parameters, you want them to have some kind of grouping. So, essentially what this will allow you to do is, it gives you a greater flexibility to figure out what kind of generalization you want to happen over the users, right. When I say find groups, right, and then assign one bandit to each group, in some sense you are making everybody in the group have the same recommendations, right, the same stories will be shown to them, right. By doing this kind of a parameterized function, so you could be sharing some parameters with him on 4 accounts, right. So, you should be sharing parameters with him on 3 other things, right. So, essentially there will be like a smoother generalization across people, right. So, the extreme case of this would be where everyone has a unique parameterization, but if you make everyone, you force them to be unique, then you are not doing much generalization, right. So, you essentially want some kind of generalization to happen. So, that will kind of fall out from doing this in a parameterized fashion, right. So, there are many ways. So, contextual bandits is just a problem setting, okay. There are many ways of solving it. One of them is to do this kind of parameterization of the value depending on the state as well as the action. So, what do I mean by the action here? The action can have parameters. So, what do I mean by that? Let us go back to the news story case, right. So, I can think of it as news story 1, I can also think of it as political article from India, right, about the central government, whatever. So, I mean I can think of some kind of attributes that describe the news story as well, right. So, these are attributes that describe my arm, they are not describing my state, they are describing my arm. So, in this case state are the people who are coming to the page and the arms are the news stories, right. So, I could have attributes that describe both the news stories and the arms, and the users, and I can use all of these attributes to define my value function. So, I can have a parameterization that depends on both the actions and the state, right, and apart from that I could have additional parameterizations like this for defining my value functions and my policies, whatever, right. So, when people talk about parameterized bandits, typically they talk about parameterizing the value functions, okay, not necessarily the policy gradient kind of things, even though this is also a form of parameterized bandits, right. When people talk about parameterized bandits in the contextual bandit case, they are talking about parameterizing the value functions, okay. And just point out these are very close and sometimes they are used interchangeably, like parameterized bandits or linear bandits, where the value function is assumed to be linear in the set of parameters that you have, right. So, that is linear bandits, right, and contextual bandits, they are often used interchangeably, but there is a subtle difference. Contextual bandits is a problem setting, while linear bandits is a specific way of solving that problem. So, contextual bandits is essentially, I mean, like I said, there are many ways in which you can solve it, right. You can just replicate the bandits, you can do group and then solve, you do not really have to assume some kind of parameterized version, but that is it. So, this is again very popular now. In fact, most deployments of bandits, right, use this kind of parameterized contextual bandits. So, for example, one of the most popular deployments of UCB, right, I told you UCB has become the most popular bandit algorithm, right, but the most popular deployment of UCB we will find is called Lin UCB, which is UCB with a linear parameterization assumed for the value functions. So, I will assume some set of parameters, I will assume my Q of A, right, that is what I am estimating. My Q of A is some function of these parameters, and that function is linear in the parameters, right. So, that is essentially what Lin UCB would do, right, and then you have to have some mechanism by which you determine what the upper confidence bounds are, right. So, it is a slightly different update rule than what we do for UCB, but it is more or less the same principle, right. So, I will be doing something like this, right. It will be something like this. So, theta 1, theta 2, theta 3 will be my parameters I assume for the representation, okay. So, fine. So, I will stop here, that will be the end of bandits. So, next class I will start with chapter 3 in the book. So, if you want to read ahead, please do so.